Good morning, students. So we have started with dual nature of matter and radiation topic. So in the last class, we discussed some definitions like what do you mean by what do you mean by electron emission, types of electron emission. Can anyone tell me how many types are there in the electron emission? Yes,
Four.
type. Yes, four types are there in the electron emission. That is photoelectric emission, field emission, thermionic emission, and the secondary emission. These are the types of the electron emission. Okay, so as the name indicates, with respect to that, whatever the external field is there, we get the photo means the electron emission. Okay, metal surface ಮೇಲೆ ನಾವು ಇದನ್ನು ನೋಡ್ತೀವಿ, and also we have discussed what do you mean by the photoelectric effect. So photoelectric effect is nothing but what? When the light falls on the metal surface, the electrons comes out of the metal surface. This phenomena is called as what? Photoelectric effect anta heltivi. Here, for this phenomena, we require some particular frequency for that phenomena. So the minimum frequency required for the photoelectric effect, that frequency is called as, yes students, what that frequency is called as? The minimum frequency required for the photoelectric effect is called as. Yesterday we have discussed that point. See, the minimum frequency required for the photoelectric effect is called as, the minimum frequency is called as threshold frequency. The minimum frequency is called as what? Threshold frequency anta ಹೇಳ್ತಾರೆ. Similarly, the minimum wavelength required for the phenomena is called as what? Threshold wavelength anta ಹೇಳ್ತೀವಿ. Similarly, the minimum energy required for the phenomena, yes, the energy is called as, the minimum energy is called as work function. Okay, so these points also we have covered yesterday. So electron emission, types of electron emission, photoelectric effect. Then in the photoelectric effect, the some of the related terms, the minimum frequency, the minimum wavelength, the minimum energy required for the photoelectric effect phenomena is called as what? Photoelectric function. Also, after this, we have discussed about the experiment also, that is the Hertz experiment, Hertz and Lenard experiment. So according to Hertz and Lenard experiment, what we have discussed, that is, here we consider the evacuated chamber. We consider the evacuated chamber. So in the evacuated chamber, here we have the cathode, here we have the anode. Okay, so this is connected to the external battery, and then next this is connected to some, this is voltmeter, and here we have the ammeter. So this is the window. When the light radiation falls on this cathode, the electrons comes out of the metal surface. So this electrons, whatever it is coming or the releasing from the metal surface, those electrons are called as photoelectrons. Those electrons are called as photoelectrons anta ಹೇಳ್ತೀವಿ. So due to these photoelectrons, whatever the current you are getting students, that current is called as what? Photo current. Yes, the current due to the photoelectrons what you are getting, that is called as the photoelectric current. So then experimental results we have seen. So what are the experimental results here? So the experimental results, we discussed that the photoelectric effect is an instantaneous process. The photoelectric effect is an what? Instantaneous process anta ಹೇಳ್ತೀವಿ. The second application, the second experimental result is what? Here the photoelectric effect, the minimum frequency is required for the phenomena, and the minimum frequency is called as what? Threshold frequency. The minimum frequency is called as threshold frequency. Here then after that we discussed the above threshold frequency. So illen threshold frequency ಇದೆ. Above threshold frequency ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ the kinetic energy is directly proportional to the frequency ಅಂತ ಹೇಳ್ತೀವಿ. Kinetic energy is directly proportional to the frequency. Okay, then after that here we discuss above the threshold frequency, one more quantity we say, the photoelectric current is also directly proportional to what? The photoelectric current is directly proportional to intensity. It is directly proportional to the intensity of light. It is directly proportional to the intensity of light. Okay, so these are the experimental results we can say for the photoelectric effect. Here we define one more term students, that is the stopping potential. So let us see what is stopping potential. So stopping potential anta andre stopping potential. So stopping potential means this is some negative potential for which the photoelectric current becomes zero. So ಏನಾಗ್ತಾ ಇದೆ stopping potential ಅಂತ ಅಂದ್ರೆ, so in the given circuit, so ನಿಮ್ದೇನ್ circuit use ಮಾಡ್ತಾ ಇದ್ದೀರಾ, you are making that circuit into a negative voltage. You are giving the negative voltage. ಅಂದ್ರೆ voltage ಅನ್ನ decrease ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. So for some negative voltage, whatever the photoelectric current is there, the photoelectric current is approaching to zero. This is called as what? ಆ ಪೊಟೆನ್ಶಿಯಲ್ ಅಂದ್ರೆ ಯಾವ ಪೊಟೆನ್ಶಿಯಲ್ಗೆ ಅದ್ರ ವ್ಯಾಲ್ಯೂ ನೆಗೆಟಿವ್ ಆಗ್ತಾ ಇದೆ, that potential is called as what? Stopping potential ಅಂತ ಹೇಳ್ತೀವಿ. So based on this fact we have seen some graph. This is photoelectric current of radiation. So as we know that above here we get with respect to the kinetic energy and the frequency, the nature of the graph is somewhat like this. So this is nu naught. Nu naught is the threshold frequency. Means initially there is no current. Okay, there is no kinetic energy. So suddenly kinetic energy matte frequency eradu directly proportional agutte when above the threshold frequency anta helbodu. Okay, so with respect to stopping potential we can see the graph as, so this is V1, this is high intensity, this is for the low intensity, this is the applied voltage anta helbodu. This is the applied voltage and this is the current. As you can see the current value is becoming how much? The current value is becoming minus. But ನೀವು ಇಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀರಾ potential ಏನಾಗ್ತಾ ಇದೆ? The potential is negative potential. Okay, it is the negative potential. Okay, so till here we have completed in the last class, so that only little I have reminded you because further points are depending on the previous concepts. So ಹಾಗಾದ್ರೆ next ಏನ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್. So this we have completed, that is experimental study of the photoelectric effect. Hertz will describe this phenomena in 1887. For that he will take evacuated glass tube, photosensitive plate, cathode irutte, metal plate, anode, then the light source, quartz window. So this experiment we have discussed. Observation also we have seen. What is the observation of the experiment? So here work function we have defined, cutoff potential. So cutoff potential is nothing but what? It is a particular frequency of incident radiation, the minimum negative potential given to the plate for which the photoelectric current becomes zero. And the stopping potential ಏನಂತ ಹೇಳ್ತೀರಾ ಅದನ್ನೇ cutoff potential ಕೂಡ ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ತೀವಿ. So please remember that stopping potential is also called as cutoff potential. So cutoff frequency, it is similar to the threshold frequency only. Cutoff wavelength, it is similar to the threshold wavelength what you have described yesterday. So these are the factors, that is the effect of intensity we have seen, it is directly proportional. Effect of potential we have discussed. Effect of the frequency on the incident radiation also we have discussed. So now next we are discussing the Einstein's explanation of the this photoelectric effect. So what is Einstein's explanation? See. So according to Einstein, here what we say, the light consists of, so ಏನ್ ಹೇಳ್ತಾರೆ Einstein ಏನ್ ಹೇಳ್ತಾರೆ, the light consists of photons ಅಂತ ಹೇಳ್ತಾರೆ. So photons ಅಂದ್ರೆ ಏನ್ ಸ್ಟೂಡೆಂಟ್ಸ್? protons ಅಲ್ಲ, okay, photons, ph. So light consists of photons. So what do you mean by the photons here? These are the small energy packets. Small energy packets are called as what? That is the photons ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so photons is nothing but what? These are the small energy packets are called as what? Photons anta ಹೇಳ್ತೀವಿ. So according to Einstein, here what happens when a light of suitable frequency falls on the metal surface? Suppose this is a metal surface, when a light of particular frequency falls on the metal surface, the photons interact with the matter. So ಇದೇನ್ ಲೈಟ್ ಇದೆ ಇದನ್ನ photon ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಐನ್ಸ್ಟೀನ್. Okay, so ಇದು photon ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಇದೇನ್ ಮೆಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಮ್ಯಾಟರ್ ಇದೆ. Okay, this is considered as matter. So when these photons are interacting with this matter and one electron is emitted due to the one photon. So ಇಲ್ಲೇನ್ ಒಂದ್ photon ಇದೆ, ಆ ಒಂದ್ photon ಇಂದ ಒಂದ್ electron ಹೊರಗ್ ಬರ್ತಾ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Okay, so similarly number of photons will be there. So similarly we will get the number of electrons from this phenomena. So this is Einstein's explanation, students. So illen energy incident ಆಗ್ತಾ ಇದೆ. Okay, so illen metal surface ಮೇಲೆ energy incident ತೋರಿಸ್ತಾ ಇದ್ದೀರಾ, ಇದನ್ನ photon ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀರಾ. So when you call it as a photon, the energy of the photon is given by what? It is h into nu. Energy of the photon ಅನ್ನು ಯಾವ ರೀತಿಯಾಗಿ ಬರಿತೀವಿ? h into nu ಅಂತ ಬರಿತೀವಿ. Nu is the frequency, h is the Planck's constant. Yes. So here this is the Einstein's explanation, students. So adra prakara Einstein ಏನ್ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ whatever the energy is incidenting, so ಇಲ್ಲಿ ಏನ್ ಎನರ್ಜಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತಾ ಇದೆ, ಈ ಎನರ್ಜಿ ಎರಡು ಕೆಲ್ಸಕ್ಕೆ ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. ಇಟ್ ಇಸ್ ಯುಟಿಲೈಸ್ಡ್ ಫಾರ್ ದ ಟೂ ವರ್ಕ್ಸ್ ಹಿಯರ್. ಒಂದು ಹಿಯರ್ ಟು ಮೂವ್ ದ ಇಲೆಕ್ಟ್ರಾನ್. ಸೊ ಇಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ಹೊರಗಡೆ ಬಂದ ಮೋಷನ್ ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಯಾವ ಎನರ್ಜಿ ಅಸೋಸಿಯೇಟ್ ಇರುತ್ತೆ? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ, ಹೌದಾ? ಸೊ ಇದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಎಲ್ಲಿಂದ ಬರುತ್ತೆ? ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ ಅಕ್ವೈರ್ಡ್ ಬೈ ವಾಟ್? ದಿಸ್ ಇನ್ಸಿಡೆಂಟ್ ಫೋಟಾನ್. ಸೊ ಇದೇನ್ ಫೋಟಾನ್ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇದೇನ್ ಎನರ್ಜಿ ಪ್ಯಾಕೆಟ್ ಬರ್ತಾ ಇದೆ, ಅದ್ರದ್ದು ಒನ್ ಪಾರ್ಟ್ ಆಫ್ ದ ಎನರ್ಜಿ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ವಾಟ್? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಸೊ ಮತ್ತೊಂದು ಪಾರ್ಟ್ ಅಲ್ಲಿ ಏನಾಗಿ ಯೂಸ್ ಆಗ್ತಾ ಇದೆ? ದ ಮತ್ತೊಂದು ಪಾರ್ಟ್ ಇಸ್ ಯೂಸ್ಡ್ ಇನ್ ದ form of work function. So what is that? Here what we said, the minimum energy is required for the electron. So here we said the minimum energy is required for the electron to come out of the metal surface. Okay. ಹಾಗಾದ್ರೆ ಇದಕ್ಕೆ ಮಿನಿಮಮ್ ಎನರ್ಜಿ ಎಲ್ಲಿಂದ ಬಂತು? ದಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ದ ಫೋಟಾನ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ಫೋಟಾನ್ ಇಲ್ಲಿ ಬಂದಾಗ ವೆನ್ ಇಟ್ ವಿಲ್ ಹಿಟ್ ದ ಮ್ಯಾಟರ್, ಅಲ್ಲಿ ಎರಡು ಕೆಲಸ ಮಾಡುತ್ತೆ. ಒಂದು, ಅಲ್ಲಿ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. ವರ್ಕ್ ಫಂಕ್ಷನ್ ಅಂದ್ರೆ ಮಿನಿಮಮ್ ಎನರ್ಜಿ ರಿಕ್ವೈರ್ಡ್ ಟು ಟೇಕ್ ಔಟ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ರಮ್ ದ ಮೆಟಲ್ ಸರ್ಫೇಸ್. ಮತ್ತೊಂದು ಎದಕ್ಕೆ ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇದೇನ್ ಇಲೆಕ್ಟ್ರಾನ್ ಮೋಷನ್ ಆಗ್ತಾ ಇದೆ ಅಲ್ಲಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಬೇಕಾಗುತ್ತೆ ಫಾರ್ ದ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಅದೇನ್ ಫೋಟಾನ್ ಎನರ್ಜಿ ಇದೆ ದಟ್ ಇಸ್ ಯುಟಿಲೈಸ್ಡ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಅಂಡ್ ದಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಎಸ್, ಸೊ ಸಿ ಅಂಡರ್ಸ್ಟುಡ್ ಆರ್ ನೋ? So therefore, ಹಾಗಾದ್ರೆ ನಾವು ಏನಂತ ಬರಿಬಹುದು ಇಲ್ಲಿ? whatever the energy is given by the photon is there, that is equal to work function plus kinetic energy ಅಂತ ಬರಿಬಹುದು. whatever the energy is there, students. So energy of the photon you might have studied in the, that is chemistry. The energy is given by h nu ಅಂತ ಬರಿತೀರಿ ನೋಡಿ. You might have studied this. So the energy of the photon is given by what? h into nu. Nu is the frequency. So nu ಈ ರೀತಿಯಾಗಿ ಬರ್ದಿದೀವಿ. ಓಕೆ, ಸೊ h into nu is equal to w plus kinetic energy. ಎಸ್, ಹಾಗಾದ್ರೆ ಇಫ್ ಯು ರಿಕ್ವೈರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ, ಇಕ್ವೇಶನ್ ಏನಾಗುತ್ತೆ? h nu minus w, ಹೌದಾ? ಸೊ ವಿ ನೋ ದ ರಿಲೇಶನ್ ಬಿಟ್ವೀನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂಡ್ ದ ವೇವ್ ಲೆಂತ್. ಸೊ ಫ್ರೀಕ್ವೆನ್ಸಿ is equal to c divided by lambda. ಹಾಗಾದ್ರೆ ನಾವು ಇಲ್ಲಿ ಏನ್ ಬರಿಬಹುದು? We can write it as it is hc divided by lambda is equal to work function plus kinetic energy. So kinetic energy is written as what? Half mv square, correct? Yes, note down this point. Yes, yesterday we have discussed the work function can also be written as it is the work function can be given by h into nu naught. Okay, it is given by h into nu naught. So nu naught is the threshold frequency. So allen ಬರ್ದಿದೀವಿ ಅದು incident frequency. Nu naught is the threshold frequency. ಹಾಗಾದ್ರೆ equation ಅನ್ನು ಯಾವ ರೀತಿಯಾಗಿ ಬರಿಬಹುದು students? h nu minus h nu naught, this equation. Okay, so illen equation ಇದೆ, this one. So here h nu minus w is equal to kinetic energy. The equation 1 I am writing it as w is equal to h nu naught. So therefore h nu minus h nu naught is equal to kinetic energy, is equal to kinetic energy. So what is common here? H is common. Therefore nu minus nu naught is equal to kinetic energy. So kinetic energy is also written as what? Half mv square. So h into bracket nu minus nu naught half mv square. Correct? ಸೊ ಏನ್ ಕೇಳ್ತಾರೆ ಅದರ ಪ್ರಕಾರ ನೀವು ಇಲ್ಲಿ ಫಾರ್ಮುಲಾನ ಮಾಡಿಫೈ ಮಾಡಬಹುದು. ಸಪೋಸ್ ಇಫ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಲ್ಯಾಂಬ್ಡಾ, ದೆನ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ as h into bracket c divided by lambda minus c divided by lambda naught. ಸೊ c ಕೂಡ ಕಾಮನ್ ಆಗಿ ತಗೊಳ್ಬಹುದು. ಫಾರ್ಮುಲಾ ಈ ರೀತಿಯಾಗಿ ಕೂಡ ಬರೀಬಹುದು. hc divided by hc ಅಷ್ಟೇ ಬರುತ್ತೆ. hc into bracket 1 by lambda minus 1 by lambda naught is equal to half mv square. ಸೊ ಮಾಸ್ ಕೇಳಿದ್ರೆ ಮಾಸ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಲ್ಯಾಂಬ್ಡಾ ಕೇಳಿದ್ರೆ ಲ್ಯಾಂಬ್ಡಾ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ವಾಟ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದಟ್. ಹೋಪ್ ಸೊ ಯು ನೋ ದ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟಂಟ್ ವ್ಯಾಲ್ಯೂ. nu naught is threshold frequency, lambda naught is threshold wavelength. Okay, Hagadre, what do you mean by nu? Nu is the threshold. Sorry, nu is incident frequency. Nu is incident frequency. Lambda kuda enagatte, it becomes incident frequency. Lambda naught and nu naught are the incident wavelength and the incident. Lambda naught and nu naught will be threshold values. Nu and lambda will be the incident values. So remember this. Yes, if this is clear, we can see the experimental results of this, what we can say, the photoelectric explanation for the Einstein's relation. Is completed. Any doubt is there in this point? So here that only it is written, you can see the energy of the quantum of radiation, kinetic max is equal to h nu minus pi naught. So pi naught w, yaudana kuda denote madbodu. So il pi naught anta confuse madkobali. This is nothing but again the work function itself. Idu kuda work function irutte. Okay. So according to Planck's quantum theory, light radiations consist of a tiny packets of energy that is called as what? Quanta. So one quantum of light radiation is called photon, which travels with the speed of light anta ಹೇಳ್ತಾರೆ. Yes. So now students, you need to remember the next point, that is the Einstein's relation. So which is very, very important. So 3 marks question they will ask, sometimes 2 marks also they will ask. So what is Einstein's explanation for the photoelectric effect experiment? Okay, so again we will write the point wise here. So photoelectric effect is an instantaneous process. So already what you have studied a little, he will modify that, but first point same ide, that is the photoelectric effect is instantaneous. Means what here? The collision between the photon and the electron, it takes place within a very short interval of time. Therefore this is called as what? Instantaneous phenomena. It is the instantaneous phenomena. Okay. So second point, if nu is equal to nu naught, if nu is equal to nu naught in the equation, so what you have the equation students? ಈಗಷ್ಟೇ ಬರ್ದಿದ್ವಿ, kinetic energy is equal to h into bracket nu minus nu naught ಅಂತ ಆಗತ್ತೆ. So suppose nu minus nu naught ಅಂತ ಆದ್ರೆ what is kinetic energy? ಯಾರಾದ್ರೂ ಹೇಳ್ಬೋದಾ? Yes, what will be the kinetic energy if in the given equation?
Half mv square.
So here, if you substitute nu is equal to nu naught, illeenagatte h into bracket, nu is nothing but nu naught itself. So therefore, nu minus nu antagatte. Nu minus nu is what? It is 0. So therefore, h into 0 is 0. So therefore, what we can say here, suppose incident frequency matte threshold frequency eradu same idre, kinetic energy of the particle will be 0. Kinetic energy of the particle will be 0 anta ಹೇಳ್ತಾರೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So based on this, the next condition, if nu is greater than nu naught, if nu is greater than nu naught, in that case, the kinetic energy becomes what, students? Here it becomes positive. It becomes positive. And the fourth case, if reverse, nu is less than nu naught. If nu is less than nu naught, then kinetic energy is what? It is negative. Kinetic energy is negative. The fifth point is the photoelectric current is directly proportional to the intensity of the incident radiation. So it is directly proportional to intensity of the incident radiation. Yes. So already what points you have studied in the previous case. So similar one, little modification is there, but first and fifth condition are same. That is, it is an instantaneous process and the current is directly proportional to intensity of the incident radiation. But with respect to frequency, we have the three postulates or the three results. So suppose the incident frequency and the threshold frequency are equal, the kinetic energy is zero. Suppose incident frequency is greater than the threshold frequency, kinetic energy positive agate. Suppose if it is less than that, kinetic energy becomes negative. Okay. So this is regarding the Einstein's explanation, students. Yes, is it clear to everyone? Yes. ಹಾಗಾದ್ರೆ what is the conclusion of this photoelectric effect? ಹಾಗಾದ್ರೆ photoelectric effect ದ್ದು conclusion ಏನಿದೆ ನೋಡಿ. photoelectric effect ನಿಮ್ಗೆ ಏನ್ ಪ್ರೂವ್ ಮಾಡುತ್ತೆ ಅಂತ ಅಂದ್ರೆ light exhibits particle nature. So heading ಏನಿದೆ lesson ದ್ದು, that is dual nature of radiation and matter. So photoelectric effect, because till now ನೀವು lighting related ಏನೇನ್ ಕಲ್ತಿದ್ರಿ, you have studied about the reflection, you have studied about the refraction. Yes, you have studied interference, you have studied the diffraction. These all tells you about the wave nature. ಇದೆಲ್ಲ ಏನ್ ಹೇಳುತ್ತೆ ನಿಮ್ಗೆ, wave nature describe ಮಾಡುತ್ತೆ. But photoelectric phenomena is the phenomena which will explain you the particle nature of the light, So therefore Einstein, what he will say, that he will prove that light behaves as a dual nature anta ಹೇಳ್ತೀವಿ. Yes. Is it clear, everyone? So photoelectric effect, experimental setup for the photoelectric effect, Einstein explanation for the photoelectric effect. So if they are asking you regarding the Einstein explanation, these 5 points only you have to describe. Just now in 5 points would it be? That 5 points only you have to tell. Okay. Understanding or no? If you have seen the yesterday's class, then you will get a connectivity. Otherwise, you may not understand, because yesterday we have defined all the basic definitions. The next point we are describing. So just now we have discussed about the photons. So photons ಬಗ್ಗೆ discuss ಮಾಡಿದ್ವಿ. ಹಾಗಾದ್ರೆ ಸ್ವಲ್ಪ points and discuss ಮಾಡೋಣ regarding the photons. So what do you mean by the photon here, students? Photon is nothing but what? It is the small packet of energy. So the small packet of energy ಅನ್ನ ಏನಂತ ಕರಿತೀವಿ? It is called as the photon. It is called as photon. So what are the characteristics of the photon? See. So these photons consist of the radiation or energy anta helbodu. Okay. So these photons are consist of radiation or energy, that is only called as the photon. Second point, the rest mass. So in photon ide the rest mass of the photon is always zero. The rest mass of the photon is always zero. Okay. The third point, the rest mass of the photon is always zero. Third point, the photons are electrically neutral. So photons ಅನ್ನೋದು ಏನಿರುತ್ತೆ, ಇದು electrically neutral ಇರುತ್ತೆ. Photons will be electrically neutral. Okay. The fourth point, the photons travel with the speed of light. Photons travel with the speed of light. Speed of light in the mu ಆಗ್ತಾ ಇರುತ್ತೆ photons. That is the fourth property. The fifth property is the momentum of the photon is given by h divided by lambda. The momentum of the photon is given by h by lambda. So P is describing the momentum, h is the Planck's constant, lambda is the wavelength. And the energy of the each photon is given by E is equal to h nu. The last point, The kinetic energy of the photon is directly proportional to the frequency. The kinetic energy is directly proportional to the frequency. Yes, so please copy down these points regarding the photons. So sometimes in the objective type questions, you may get this. So photons are small packet of energy. It consists of the radiations. The rest mass of the photon is zero. These are electrically neutral. They travel with the speed of light. The momentum of the photon is given by P is equal to h upon lambda, and its energy is given by E is equal to h nu. And the kinetic energy is directly proportional to the frequency for the photons. Copy down these points. Okay. So next one. So the next concept, very, very important part of the lesson, that is de Broglie hypothesis. So what is de Broglie hypothesis? Let us see here. So here the de Broglie will say like radiation matter also has the dual nature. So ಯಾವ ರೀತಿಯಾಗಿ ಈಗ that is the like radiation ನಮ್ಗೆ ಈಗೇನ್ light radiations ಇತ್ತು, it is showing both the matter as well as particle as well as the wave nature. So similarly, de Broglie will say that matter also has the dual nature. So dual nature andre this is also having the particle nature, this is also having the wave nature. Okay. So here when the matter is in motion, the velocity with this matter is called as what? Wave velocity. It is called as what? Wave velocity. So what is wave velocity here, students? So that is nothing but the velocity associated with the matter when it is in motion is called as what? Wave velocity anta ಹೇಳ್ತಾರೆ. So what are matters? These are waves associated with the moving particles is called as what? Matter waves. So matter waves, when they are in the motion, the velocity associated with that is called as what? Wave velocity, or it is also called as matter wave velocity. Okay. So who proposed this? The de Broglie will propose this one. Okay. So what de Broglie is saying here, students, matter also exhibit the two nature, that is the particle nature and the wave nature. So for that we have the wave velocity term. So wave velocity is the velocity associated with the particle when it is in the motion is called as what? Wave velocity. So ಹಾಗಾದ್ರೆ ಇಲ್ಲೇನ್ ನಾವು ಡಿ ಬ್ರಾಗ್ಲಿ hypothesis define ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ನಾವು ಡಿ ಬ್ರಾಗ್ಲಿ wavelength ಅಂತ ಒಂದು expression ಬರುತ್ತೆ students. Please copy down this. The de Broglie wavelength is given by it is h divided by p. So wavelength is equal to Planck's constant divided by momentum. So this is nothing but h divided by momentum, that is mass into velocity. But so this is h divided by mv. But here the light we are considering for photon. ಹೌದಾ ನಾವು ಫೋಟಾನಿಗೆ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. So photonic ಹೇಳ್ಬೇಕಾದ್ರೆ the velocity v becomes the what? That is velocity of light in the free space. So therefore it becomes h divided by m into c. So this expression here, students, ನಿಮ್ಗೆ ಏನ್ ಇಲ್ಲಿ ಲ್ಯಾಂಬ್ಡಾ is equal to expression ಬರ್ತಾ ಇದೆ, that is lambda is equal to h divided by mv. This expression is called as de Broglie wavelength. So lambda ಅಂದ್ರೆ ಏನು? Wavelength. So this is called as what? De Broglie wavelength of the particle. De Broglie wavelength of the particle, that is h divided by m into v. Yes. So the new formula in this chapter now. So till now we discussed about only Planck's constant, then kinetic energy, work function formula, Einstein's relation. Now the de Broglie wavelength is given by h upon m into v, or lambda is equal to h upon m into c. Okay. So now we can write this formula. Andre lambda vanna barditkoli in terms of kinetic energy kuda baribodu students. It is h divided by under root of 2 m into ek, where ek is the kinetic energy, m is the mass. So h divided by under root of 2 m e k. This is in terms of kinetic energy. One more formula for the lambda. Though derivation illa, there is no derivation in this chapter. Okay. So the lambda is equal to h divided by 2 m e k aitu. In terms of potential also we can write it 2 m q into v. So first expression in terms of momentum, mass into velocity. Second equation in terms of mass and velocity, but velocity of light in the vacuum. Third formula is in terms of the kinetic energy. It is lambda is equal to h upon root of 2 m e k. Similarly, for in terms of potential, it is lambda is equal to h upon root of 2 m q into v. Suppose idu electron idre, charge q badlagi electron idre naven madbodu, we can take it as 2m into e into v. M is the mass of the electron, e is the charge of the electron under root of v. So whatever the potential they will give you. So potential ಮೇಲೆ ನಿಮ್ದಿಲ್ಲಿ lambda value depend ಆಗಿರುತ್ತೆ. Because h constant ಇದೆ, 2 is constant, m is constant, e is constant. So ಏನ್ ಹೇಳ್ಬೋದು ನಾವಿಲ್ಲಿ? We can say that lambda is inversely proportional to root of t, root of v. Here copy down all the formulas with respect to the de Broglie wavelength. Yes, other than this, what all formulas we have discussed? So first, work function is also given by pi, which is equal to h mu naught. This is for the work function. Then next we discussed about the, in terms of lambda, hc upon lambda naught. Then next, Einstein's relation. So according to Einstein's relation, it is kinetic energy is equal to h into bracket nu minus nu naught, or h into bracket 1 by lambda minus 1 by lambda naught. This is for the kinetic energy. This will be hc. Or in general, we can write kinetic energy is equal to energy of the circle, energy minus work function. Kinetic energy is equal to E, this is E is H nu. E is H nu here. Okay. Then after that, de Broglie equations. So kinetic energy half mv square, no doubt. ಅದನ್ನ ಬಿಟ್ಟು frequency ಯಾವಾಗ 0, that is nu is equal to nu naught ಇದ್ದಾಗ, nu is greater than nu naught, nu is less than nu naught, we have seen the conditions just now. So please remember all these formulas, students, and remember the formula with respect to the de Broglie wavelength. ಈಗಷ್ಟೇ ಬರ್ದಿದ್ವಿ. So de Broglie wavelength is given by h upon mv or h upon m into c. Lambda is equal to h upon root of 2 me is equal to h upon under root of 2m qv. So q ಬದಲಾಗಿ charge of the electron e ಅಂತ ಕೂಡ ನಾವಲ್ಲಿ ಹಾಕ್ಬೋದು. Okay. Yes, is it clear? Any doubt is there till now? Okay. Yes. So one last point is remaining in the lesson. So again, this is a small lesson, that is Davison and Germer experiment. So tomorrow we will discuss the Davison and Germer experiment along with the questions and the numericals. So please recall all the formulas tomorrow. We will continue. Okay, students. Thank you.